All right, to start the try two off here, we're going to jump right into some algebra stuff with some geometry things. But for the next few lessons here, I think we're going to be going back over some of the algebra skills that you may have learned and then incorporating it into some of the geometry concepts and ideas that we had already talked about this year and will continue then to use in this next unit. So the first two things we want to talk about, there are two formulas. We're going to be talking about a lot of coordinates in this unit. The XY coordinate plane with different points that we're going to be working with. And so the first two things we want to talk about is based on the idea that if you have 2 points, okay, if you have 2 points on the coordinate plane, get that out of here. If I can zoom in here. If you have 2 points on the coordinate plane, say you have some x1 and say you have a y1 coordinate, so that's just a pair of numbers for one coordinate, and then you have a second coordinate, some x2 and y2 numbers that are together a location on the coordinate plane. You can have two formulas here to figure out two things. One is how far apart or what's the distance between those 2 points. And so that formula can be calculated for d for distance is the square root of, and it's a big square root here, but just gives us some room to write here. It is the difference of the x coordinates squared plus the difference of the y coordinates squared. Okay? So if you plug in those 4 numbers, x1, y1, x2, y2, plug those in, simplify, you will get how far apart those points are. And then the second formula here is the midpoint formula. So if you had a segment that had its endpoints at x1, y1 and at x2, y2, you could find where on the actual coordinate plane, what location, what coordinate would the midpoint be for that segment. And that is calculated by capital M being the midpoint. It's simply just really the averages of the x's. So x1 plus x2 over 2, comma, and then the averages of the y's. y1 plus y2 over 2. And so just finding the coordinate. It's a weird formula because I think most times we think of formulas as they're going to give us a specific number value versus this one's actually just giving us the location of where this coordinate is. And so now if we can apply that to just working through some of these questions down here, things like finding the midpoint of a segment with the endpoints of -8, 2 and 4, 16. So I usually just like to label my values when I'm working with them just because I know a common mistake that people get is they will mislabel or reuse one of their numbers twice. So just making sure you're being careful, being organized, and not losing track of that. But the midpoint formula here is just x1 -8 plus x2 over 2, comma, y1 plus y2 over 2. And so the midpoint here would be at -8 plus 4 would be -4 divided by 2 would be -2, comma, and 2 plus 16 would be 18 divided by 2 would be 9. So the actual location of that midpoint between those 2 points they gave us would be -2, 9 on the coordinate plane. So then you could also use, again, an example here like this for the distance formula. If you needed to find the length of a segment with those 2 endpoints, or if you had to find the distance between these 2 points, it's the same idea. And again, I usually just label things in the order they gave it to me because I don't need to think harder than I have to on this. But the distance then would equal the difference of the x values. So if I did -5 for x2 minus x1 would be plus 3 then, quantity squared, plus, and then it's the difference in the y value, so that'd be 8 minus 5, quantity squared. Simplifying each of those, let's see here. -5 plus 3 would be -2. -2 squared would be a 4 plus. 8 minus 5 would be 3. 3 squared would be a 9. And 9 and a 4 added together would be a 13. And you can't simplify the square root of 13, so that would be my exact distance between those 2 points. Now, if they wanted a decimal approximation, we could use our calculators to get that, but we're going to try and keep things as simplified as we can in this unit. So now a couple of definitions or a couple of terms that we just want to make sure that everyone's aware of. So when we were talking about points, lines in the first trimester and angles and things like that, when we start to take things up kind of a level of dimension at least, points and lines are usually just seen as either one-dimensional or zero-dimensional technically for points. But once you go to two-dimensional, I mean, you think about two-dimensional drawings and two-dimensional surfaces, we now start talking about things like planes. Planes are just surfaces in which if you have 2 points in a plane, we can say then and describe that surface as the surface containing all the points of the line that would contain those 2 points. But in layman's terms, again, a plane is simply just a flat surface. You can think of the floor as a plane. It's not going to be something that is curved, but we could extend it on forever in all directions. Even if you thought of the ceiling as a plane, if you thought of the piece of paper you took a quiz on as a plane, the screen on your iPad is a plane. So we have all these two-dimensional planes all around us. Then we have these 2 other terms or adjectives here. Things that are known to be coplanar are things that are in the same plane. They lie in the same plane. Again, this is hypothetical, but if the feet of your desk are not wobbling around too much and they're all touching the floor, those points of contact are said to be coplanar. They're a part of the same surface. But things that are not coplanar, things that are not a part of the same surface as one another and do not lie in the same plane, those things are said to be non-coplanar. So now we got to start talking about some particular angle relationships here. But before we get to those, we have to define some things first. When we talk about lines and how they're intersecting, and there's specific relationships that incorporate 3 lines. One of which is known as a transversal. A transversal is a line that simply just intersects 2 other lines at 2 distinct points. And so, for example, in this diagram here, line A would be a transversal because it crosses and intersects the other 2 lines, but it also specifically crosses them at different points. Now, if it was drawn more so like this, where I had 2 lines like this, and then all of a sudden I was trying to make the argument that this was a transversal, that line crosses those 2 other lines at 1 point, not 2 distinct points. So in that case, it would not actually qualify to be a transversal. Okay, so in this diagram, line A would be the transversal, and so for the sake of just labeling these things, I'm going to call this one line, let's go with line P, and we'll call this one line Q. Okay, so line A is the transversal, and it crosses these 2 lines here, P and Q, and now with P and Q, they've actually created certain regions in this plane that they exist in, this certain surface that they exist in and lie, and one of which is the interior region. That's the space simply just between or inside these 2 lines. So this would be considered the interior region. And then you have the rest of the actual kind of plane, and that would be everything else. So outside of that exterior region, and even if you extend these lines in both directions forever, you would have the exterior region over here, and you'd also have more of the exterior region over here as well. And so with those, that is actually going to help us then define and name and identify some particular angle relationships when we look at these kind of diagrams. And so when we're looking at examples like this, if I take kind of the same exact things that we were saying before from the last slide, I'm just going to use, line A is our transversal again, and why not? I might as well just name these again, like, line P and line Q. You can name them any lowercase, cursively looking italicized letter, but line A is our transversal. P and Q then would be our two other lines that it intersects at two distinct points. There are particular angle relationships we want to point out to you. Okay, the first one is a relationship for angles that we call alternate interior angles. And so angles that we refer to as alternate interior angles are two things. They are two angles that are, you guessed it, both found in the interior region. However, they are two angles that are in the interior region that are at two different intersection points. So again, we're not talking about angles 2 and 7 because those have the same exact point that they are located at. But the alternate part of this naming is that these angles that are alternate interior angles are going to be on alternating sides of the transversal. So for example, two angles in this diagram that would be considered alternate interior angles would be angles like angle 7 and angle 3. If you look at those two angles are located in the interior region. They're at two different intersection points here, and they're on alternating sides of the transversal. They're on opposite sides of the transversal. One's on the left, one's on the right, if you want to look at it as left and right. Okay. Another pair of alternate interior angles would be angles like angles 2 and 6. Those two are known and referred to as alternate interior angles in this diagram. Okay. The next pair of angles that you have there are what we call alternate exterior angles. Now, if you're taking the first one we talked about, you could probably guess which ones are going to be the alternate exterior angles. So angles that are both in the exterior region, they are both at different intersection points, and also, again, they are on alternate sides of the transversal. So these would be things in pairs like angles 1 and 5, and angles like 4 and 8. Okay? So again, alternate interior, alternate exterior, they're very straightforward as far as if you understand their naming and why they're named what they are, it kind of tells you exactly which ones you should be picking. Okay? Corresponding angles then. Corresponding angles are a couple things. Okay? Corresponding angles are angles that, the way I think of it is, if you're looking at these two intersection points, okay, in the same way that we said it in the previous units with congruent triangles, there were corresponding parts, corresponding angles and sides. They were in the same location or kind of part of the triangle in each one of the two triangles. And it's the same thing here. These corresponding angles are at the same location at each one of these intersections, at each one of these different points. And so things like angles 1 and 3 could be considered corresponding angles. If you look at angles 1 and where angles 1 and 3 are, they are in the same corresponding location at each of these two intersections. Now, the actual definition for corresponding angles are two angles that are located at two different intersection points of a transversal and two other lines. So check. They are not only on the same side of the transversal, but one of them will be in the interior and one of them will be in the exterior. So notice 1 is in the exterior region, 3 is in the interior region, and so again, that would make them corresponding. Other corresponding angles you see in this would be things like angles 2 and 4, angles 8 and 6, and angles 7 and 5. So there's quite a few pairs of those, but again, just understand that relationship, corresponding angles, okay? And then the last two here are kind of similar in the same sense as the first two, but now we're talking about not alternating, but we're talking about same side interior angles. So before we said alternate interior angles would have been things like 2 and 6 because they were on the interior and alternating sides of the transversal. Same side interior angles are going to be interior angles again, but now they're on the same side of the transversal. So this would be relationships for angles like 2 and 3. Those are two interior angles at different intersection points here that are on the same side of the transversal, yet both in the interior. So 2 and 3, 7 and 6, or 6 and 7, those two angles could be same side interior angles. And then if you keep applying this kind of logic, hopefully you can kind of guess here, same side exterior angles then would be angles like 1 and 4. So angles like 1 and 4, angles like 8 and 5, again, just examples of those. But these are the 5 kind of key relationships that we want to point out when you have a transversal that intersects two other lines and creates these different angles at these two intersection points. And so as these diagrams get more complex and as these diagrams start to fill up with more lines and more points and more complexity, it's going to take a little bit of concentration on your part to kind of acknowledge, okay, what do I really need to focus on here in order to kind of make these angles tie together? And so a couple things. When we're talking about those relationships on the previous slide, one of the things that you know for sure is that the transversal will be the line that kind of joins these angles together. In each of these 5 relationships on the previous slide, the line or segment or part that kind of draws them to each other is the transversal. And then the other 2 lines that help create the actual angles and finish them, those would be the 2 lines that your transversal crosses. So in this case, like this example here, if I looked at angles 4 and 5, if I was looking at angles 4 and 5, okay, 2 things here. One, I can tell by looking at those 2 angles, if you were to connect them and find the line that kind of just strings them together, that would serve as our transversal. So that would be, again, things like this line coming through here. And so when you see that line there, connecting these alternate interior angles, the other 2 lines that help now finish and form the actual 2 angles you're talking about, those would be the 2 lines that would make these 2 angles alternate interior angles. Okay, so again, just getting used to that identification here. So these would be the 2 lines that you see here. I know I don't have any points and letters here labeled for you, but just to make the point here that those 2 red lines you see there would be the lines that would be the ones we need to focus on for angles 4 and 5 to be alternate interior angles. Okay, if you look at the next one here, if you look at what lines are angles 3 and 6 alternate interior angles for, well, again, if you take a look at those 2 angles, angles 3 and 6, I see my transversal. I see my transversal there. The 2 lines that these 2 angles 3 and 6 would be alternate interior angles for are the 2 lines here, one that would finish making angle 3, and the other one down here, the one that would finish making angle 6 for me. So again, those 2 lines with that blue transversal, those would be the ones that would make these 2 angles 3 and 6 alternate interior. Okay. Now the last one here is a little bit weird because you kind of don't have an angle to connect it to because they're asking for one. But specifically, they are asking for an angle that would make this angle 9 a corresponding angle. And so when you look at this diagram, again, these corresponding angles are just like the other ones. They are connected to other angles with a transversal. And so if I head this direction, like if I'm going to make the argument that this is going this direction here, if I try to connect it with angle 5, the problem is here is that this line that makes angle 9 and this line here that makes angle 5, corresponding angles, one has to be on the interior and one has to be in the exterior. Angles 9 and 5 here are both in the interior, so that can't be. If I start looking at angle 6 actually, I haven't fully made angle 6 here. I would need another line to kind of make angle 6. But again, the transversal and the two lines that it intersects should be enough to make the two angles that you're talking about here. So it can't be 5 and it can't be 6. So if I'm not going that direction, maybe I'd have to figure out a different way to go here. So angle 9, what if I went with the transversal this way? And so I have one line here that formulates and makes and creates angle 9, and then I have this line here. Now between angles 1 and 2, there's only one of them that I would actually consider corresponding to angle 9. It can't be 1 because 1, again, would be in the interior. But angle 9's in the interior, and corresponding angles, you have to have one of each. So this is why it would have to be angle 2. Angle 2 is an angle that's corresponding to angle 9. It is on the same side of the transversal, and 1, angle 9, is in the interior, and 2, angle 2, is in the exterior. That fits the definition and description for corresponding angles. So, all this being said here, when you look at this diagram and you look at this picture, this is just one drawing where you could be asked a whole mixture of questions about, okay? I mean, we could say, you know, what angle is angle 2? What angle is angle 2 alternate interior angles with? And you could look at this diagram, try and figure it out, and kind of piece together an idea, but just it all comes down to seeing and practicing, seeing your transversal, and seeing then the different angles that are being formed here, and finding the one that fits that definition for things like alternate interior, same side interior, corresponding, alternate exterior. And so it's just going to take practice, but we'll keep practicing it together. So here's where we're going to dabble back into our algebra here, okay? I know you all maybe feel certain ways about that. Maybe some of you feel really good about that. Maybe some of you don't feel really good about that. But either way, we're going to take time to just review some algebra things, mainly with slope. Okay, the slope of a line, I mean, we talk about the slope of a line in so many different ways throughout your algebra classes. Whether people refer to your slope of your line being the rate of change, or maybe some people refer to your slope as the change in y's over and compared to the change in x's. Some people refer to the slope of a line as the rise over run. There's so many ways that you could actually just talk about slope and kind of refer to slope in different contexts, science classes and math classes. And so it just kind of depends on how you kind of see it. But at the end of the day, the real thing that we want to focus on is how do you actually find slope? So this goes back to kind of the first few things we were talking about. If you were given 2 points, some x1, y1, and some x2, y2 that your line passed through, okay? You could calculate the slope of the line that goes through those 2 points, slope being referred to here not as capital M, but as lowercase m. The slope formula for those 2 points, the line that goes through those 2 points, would be y2 minus y1 over x2 minus x1. And so that formula to find your slope, to calculate slope, is going to be a pretty integral part of what we do in this unit, especially with a lot of the lines that we're going to be talking about. And with slope then comes kind of 4 different scenarios here. When we are graphing slope on the coordinate plane, it's going to produce a couple different visuals for us here. Okay, so again, picture this being the x and y coordinate plane here. Just doing some quick little drawings here for us. So when we're talking about the different possibilities with slope, okay, one of the possibilities is that your slope of your line could be positive. With positive sloped lines, your line or your graph or the visual for it, you should be having a line that increases or goes up from left to right. Versus if you have a line that has a negative slope, you should have a line that is falling from left to right. Now, it doesn't have to fall super quickly. It could fall very slowly over time, but nonetheless, it's falling as your eyes are going from left to right like you're reading. Thirdly, you could have a slope that is 0. 0 for your slope is also what we would kind of relate to and connect with a horizontal line. Okay, let's just make a note of that. Horizontal line is going to have a slope that is 0. And then finally, an undefined slope. Now, undefined slope, again, it's still a slope. We just don't really know how to explain it to you because it's undefined. But it still produces a line. It still creates a visual for a line. That line is usually, and will always end up being, a vertical line. So again, just like slopes of 0, if your m equals 0, that's a horizontal line we're talking about there. If your slope is undefined, that is a vertical line that we're talking about, okay? Now, the last things here before we get to the last two slides, parallel lines, okay? Parallel lines, a couple of things to note about them. Parallel lines are two lines that are never going to intersect, okay? They will never intersect. They will never cross paths. They won't come in contact whatsoever. But more importantly about their slopes, parallel lines have the same slope. If the slope of one of these lines was, say, positive 1, this line that's parallel to it will also have the exact same slope. Perpendicular lines, now we've talked about what perpendicular means. Perpendicular lines intersect to form right angles. We've talked about that in the last trimester. However, when we're referring to it in terms of slope, okay, perpendicular lines have not the same slope, not even close. But they have two things. Their slopes are opposite reciprocals. Opposite reciprocal slopes. And so what that means is, for example, if one of your slopes was 1/7, the other slope would be two things. It would be the opposite, meaning I would change the sign. So my first one was a positive 1/7. My other slope that's perpendicular to it would be opposite, negative. And reciprocal just simply means you are flipping this and you're switching the numerator and denominator. So this would be 7/1 or just 7. So a slope that's 1/7 is perpendicular to a slope that is -7. Or even things like if you had a slope that was -3/4, a slope that's perpendicular to that one would be opposite, positive, and now reciprocal 4/3. Okay? But those things still tie together. I mean, those slopes of those lines paired up still are perpendicular. They still would make lines that visually form right angles. But again, just highlighting the connection and relationship between their slopes is what we're kind of focusing on today. So one of the things that you're going to want to make sure you're practicing and that you're taking time to make sure that you're able to do in this unit is make sure that you're able to do slope calculations fairly efficiently in a fairly consistent manner. So again, just making sure you're aware, if you are asked to find the slope of a line that passes through these points, the slope of a line that has endpoints, or maybe the segment has endpoints of these 2 points, you're going to want to make sure you're able to just do those calculations. Again, however detailed you feel like you need to be, I always end up feeling like I need to label these things. But just putting them together in your slope formula, y2 minus y1 over x2 minus x1. And then going from there and just simplifying until you can't simplify any further. Just finding your slope. Again, just making sure that you're being consistent on your calculations, that you're not switching up and mixing the formula, because the formula kind of stays the exact same no matter which way we're doing this. Y2 minus y1 over x2 minus x1. And so once you get these things like this, though, just remember when you're dividing by 0, this is a slope that is undefined. Your calculator is going to tell you error. Your calculator is going to tell you that it can't do it. But that is an undefined slope, dividing by 0. Differently, though, from that, y2 minus y1 over x2 minus x1, when you take 0 divided by something else, that is a slope of 0. Okay? So again, doing your slope calculations, you have your formula. It's not going to change, so make sure you have that written down somewhere that you can see it if you don't have it memorized, but make sure you're turning back to it and not forgetting it. So last slide here, just want to talk through a couple things because this is where we start the process to get things incorporated back into how we were kind of talking about things before in the earlier trimester. Okay, given these 2 points or 3 points, A, B, and C here, A is at negative 210, B is at 6.5, and C is at negative 4.3. You could answer a whole just series of questions about these points. For example, find the slope of the line that is parallel to AC. So if I'm looking for a line that has a slope that is parallel to AC, well, if I find AC's slope, the line that's parallel to it should have the exact same thing. So if I find the slope for AC, so I got A's point here at negative 210, and C's point is at negative 4.3. If I find AC's slope, y2 minus y1 over x2 minus x1, if I find this slope of 7/2, I know that my line that they're talking about, the slope of a line that's parallel to it, should have a slope that's the exact same thing, 7/2, 7 over 2. Carry that on to the next problem below here. Find the slope of a line perpendicular to AC. Well, now, if I know that my line's perpendicular to AC, I know that I should have a slope that is opposite reciprocal to AC's slope. So if AC, in the problem above, had a slope of 7/2, my slope here for this problem should be a slope that is the opposite reciprocal. So 7/2, opposite's negative. Reciprocal would now be not 7 over 2, but 2 over 7. So again, answering questions like this, just going from one thing to the next, okay? But now the last two here, tying it back into some of the things we talked about before. Find the slope of the line that is an altitude that goes from A to BC. Now remember, an altitude goes from a point, a vertex for a triangle, and these 3 points could make a triangle, goes from a point that is a vertex, A, to the opposite side and is perpendicular to it. So if it goes from A to side BC, I know it has to be perpendicular to BC because it's an altitude. So if I look for the points that would be the slope then for BC, it's kind of the same thing as the second question. If I know this thing's slope, y2 minus y1 over x2 minus x1, that's a negative 2 over a negative 10, that'd be a 1/5. That's the slope of BC. My altitude that goes from A to BC would be the opposite reciprocal. So the opposite reciprocal of 1/5 is negative 5, or negative 5 over 1, which again, that simplifies to be negative 5. And here's the last one then. Okay, I just want to visualize this with you for a second. I know I'm not drawing this thing to scale at all. However, if you think about this, A, B, C, however it's oriented, find the slope of the line that is a median that goes from A to BC. Now remember in the last trimester, we talked about medians go from a vertex of our triangle to the opposite side's midpoint. So yes, I know the slope of this line passes through this point here, A. This point here, A, which is negative 210. But this point now, this median of mine doesn't go through B. It doesn't go through C. It actually goes through M, the midpoint of BC. So in order to actually do this slope calculation, I need to figure out what is the actual midpoint location for this side BC. So now instead of doing slope calculation, I'd actually need to do the midpoint calculation with B and C. So again, if I'm looking up here at B and C, it's the average of the x's, so 6 plus or minus here, plus a negative 4 would be 6 minus 4 over 2, comma, it's the average of the y's, 5 plus 3 over 2. Looks like the midpoint is located at, I'm going to put it up here as I write it down. Midpoint would be at 2 over 2, which is 1, comma, 5 plus 3 is 8 over 2, which is 4. So the slope of the median is the slope of the line that goes from A to M. So now if I use these 2 points to figure out my actual slope, y2 minus y1 over x2 minus x1. Negative 6 over 3, that is negative 2 for my slope for that median. So you see here how we're taking algebra ideas and now we're starting to infuse it and connect it and relate it to some of the geometric concepts and ideas that we talked about earlier this year. So for your homework, you have worksheet number 1, Unit 5, worksheet number 1 on Google Classroom. Take time to go through it. I will be back then on Wednesday, which should be tomorrow then when you're seeing this. So please make sure you're getting this done. Come with questions. If you have questions, come in the morning. Just remember then we will move on to the next lesson, which is going to take things a little bit further here, but still just kind of focusing on some algebra review kind of concepts that tie in now to our geometry content. So we'll see you all later. Again, stop by if you have any questions before class on Wednesday, and we'll see you then.